Hello dear students. Today we are going to learn a topic called as terminologies used in drives. So the flow of our lecture will be what are the objectives, outcomes, terminologies, a reference from which I have taken the material, and the last is question of the day. So what is the objective? The objective of this session is you should be understanding the drive terminologies. Outcome will be you need to apply all this to calculate the dynamics of a motor. So what are the terminologies? Force, torque, speed, acceleration, inertia, work, power, horsepower. These are the listed terminologies. So in this case, what do you mean by force? For doing some work or to move a particular object from one place to another, I need to apply some force. We usually say this statement: apply a greater force, apply a less force, all that. So what do you mean by force? It's nothing but a push or pull. What is torque? Okay, force is nothing but a push or pull, but what about torque? Torque is the terminology which will help you to understand how much force will be required for that object to rotate, to come in motion. Yes, then speed. Speed is by what speed you want to control the motion of that object. यानी कि धीरे चलो, fast chalo, you drive it speedily, you drive it slowly. So slow and fast are nothing but speeds. What do you mean by acceleration? Acceleration is again the same, related to speed, but how fast I want to reach to that point will be defined by acceleration. That is, for example, in 10 seconds I want to accelerate my drive, I want to accelerate my device that it should reach to that point. So that is what is acceleration. Inertia. Inertia is a concept by which most of the things are dependent. Like in most of the applications, inertia is the particular energy which you want to overcome of a particular object so that it can be entered into motion. We need to waste a huge amount of energy to overcome this inertia, because what happens, the objects or the applications like blowers, ship propellers, flywheels, then one more is there, locomotives, many more are there, but these are few to list. So they are having very high inertia, and to overcome this we need to apply some force. What is work power? You all might be knowing. Horsepower. Now what do you mean by horsepower? So this is unit of power. This was invented by this person called as James Watt. So the person used to sell steam engine. One day some person asked him how many horses one steam engine would replace. So this was the question to him. He found that a horse would average about 550 foot-pounds of work per second. Therefore 1 HP is equal to 550 foot-pounds per second, or 33,000 foot per minute. This was the story behind this horsepower unit. It's nothing but the same again, that how many horses can provide me the power which is required. So we are not going to use horses, but we are going to use a motor, so that our target will be achieved. Okay, so now let's discuss a bit more. Here in the diagram you are getting that force is nothing but push or pull, as stated earlier. In this case there is addition of forces. Yes, so this is 10 pound force, 10 pound force, they are in the same direction, and so the total is 20 pounds force will be acted. Suppose I have an object here and I want to displace it from point A to point B. So this will be the force which will be added and it will move. Okay, this is the object here again, but these forces are in opposite direction, 10 pound, 10 point, but they are acting in opposite direction, and so the resultant force on that object will be 0. So whenever we are going to apply some force, then the direction also need to be taken into consideration. See, both are in the same direction, the force will be added. Both are in opposite direction, they will be subtracted. And if at all, consider the case like it is 10 pound, here it is 5 pound. What will happen? The resultant will be 15 pounds. Yes, here it is 10 pounds, here it is 5 pounds. What will happen? It will be 5. The resultant will be 5 pounds. Okay. This is one concept. Let's talk about this. What is torque? As I told you, that torque is a twisting or turning force, okay, which I need to cause a rotation in an object. Yes. So here you could see the force of 10 pounds is applied by this person, and this is a radius of 1 foot. Okay. So he is going to apply 10 pounds force, and the radius is 1 foot. So the torque will be 10 foot-pound. But as I increase the rod, what happened? I applied the same force, but the torque was greater. It was 20 foot. Okay. So this is what is the concept of torque. In simpler terms, अगर हमें किसी चीज़ को रोटेट करना है, किसी स्क्रू को टाइटन करना है, किसी मोटर को घुमाना है, तो इस केस में मुझे कुछ टॉर्क देना पड़ेगा. So that torque is nothing but a force into radius by which I want to rotate that object. That's it. Okay. So one more concept I forgot to tell you. In this, देखो 10 पाउंड का ही फोर्स किया है, बट रेडियस बढ़ा दिया. Yes, so this is used where we want to open a wheel of our car. तो जो मैकेनिक होता है ना, तो मैकेनिक वो व्हील जो है हमारा खोलता है हमारे गाड़ी का. तो when he opens that, at that time he had some handle, तो उसका लेंथ ज़्यादा होता है. तो how he does it, लेंथ बढ़ाने के बाद उतना ही फोर्स उसके ऊपर एक्ट होगा, लेकिन लेंथ बढ़ाने की वजह से टॉर्क बढ़ जाएगा. सो टॉर्क बढ़ेगा तो वो जल्दी से काम कर पाएगा. सो दिस इज द कंसेप्ट वेयर वी यूज टॉर्क. ओके. नाउ लेट्स टॉक अबाउट स्पीड. सो स्पीड इज नथिंग बट डिस्टेंस अपॉन टाइम. यू ऑल माइट बी नोइंग. सो एन ऑब्जेक्ट इन मोशन takes time to travel from one distance to another distance, or from one point to another point. Linear speed is the rate at which an object travels a specified path. Okay, that is, this is linear speed. The point is A, here it is point B, and the vehicle is going to start from point A and reach to point B. This is nothing but a linear speed. It is going to travel in only single direction. Okay. Now angular speed. So in angular speed, the object is going to rotate. Okay, so it is also called as angular speed. It is also called as rotational speed. It determines how long it takes for an object to rotate a specified angular distance. That means the speed is going to determine, that is, how long will it take for the object to rotate in a specified angular distance. That is nothing but called revolutions per minute. I will repeat again. Angular speed, it is also called as rotational speed. It determines how long it takes for an object to rotate a specified angular distance. So अगर यहाँ से यहाँ तक जाना है तो उसका RPM कितना होना चाहिए? What should be the angular speed? That's what we get from this. Acceleration. And acceleration in speed is what? It is an increase in speed. And what is deceleration? It is a decrease in speed. So here I have 10 RPM. I increase the speed. It is 20 RPM. It was 20 RPM. I decrease the speed. So it is 10 RPM. Okay. Now let's check why this happens. This happens because suppose that my car was moving and suddenly I started to climb a hill using my car. So there was a need for my car to accelerate. That is, उसका लोड बढ़ गया. जो वो स्टीप स्लोप के ऊपर, स्टीप रास्ते के ऊपर जा रहे थे या लीनियर रास्ते पे जा रहे थे, तब उसको उतनी फोर्स की ज़रूरत नहीं पड़ी, उसको इतना पावर पिकअप करने की ज़रूरत नहीं पड़ी. बट व्हेन इट स्टार्टेड टू राइज अप हिल, एट दैट टाइम एक्सेलरेशन केम. अनटिल अनलेस आई एक्सेलरेट, मेरी गाड़ी आगे ही नहीं जाती. सो दिस इज वेयर इट केम. वेयर इट कम्स डिसलोरेशन. अब वही गाड़ी ऊपर से नीचे आ रही है. यस, एट दैट टाइम ऑटोमेटिकली द लोड डिक्रीज, क्योंकि ग्रेविटेशनल पुल भी उसको खींच रहा है, तो को लगने वाली पावर कम हो गई, इसीलिए ऑटोमेटिकली मेरी गाड़ी ने डिसलेट करना पड़ेगा. So why I am telling you all this? Because these concepts are present in all the hybrid electric vehicles, how a electric car actually operates. So most of these concepts are directly used as it is in electric drives or electric vehicles. Now let's go to the next point, that is inertia. Yes, the law of inertia states that an object will tend to remain in its current state of rest or motion unless acted upon by an external force. Yes, it's very clear, because अगर कोई बंदा बैठा हुआ है, जब तक वो उठेगा नहीं या उसको किसी फोर्स से एक्सर्ट नहीं करोगे तो वो काम नहीं करेगा. He is not going to move from that position. काम नहीं करेगा, यानी कहना का ये है कि he is not going to move from one position to another. तो वो जो कुछ उसकी पावर होती है खुद की, वो उसको अपोज करना है, उसको ओवरकम करके हमें गाड़ी को घुमाना है, उस बंदे को काम करने के लिए लगाना है. तो दैट इज नथिंग बट इनर्शिया, एंड आई वांट टू ओवरकम दैट इनर्शिया. फॉर दैट पर्पज अगेन आई नीड टू कैलकुलेट हाउ मच फोर्स नीड टू अप्लाई for that to overcome the inertia. Inertia is nothing but a resistance to acceleration or deceleration, and you also call it moment of inertia. Now the next one is work. Work is defined as a product of net force into displacement. Then we can say that work is done. अभी समझो कि हमारे पास दो ऑब्जेक्ट्स हैं and I want to pick one object from point A and place it in B. तो मैंने सिर्फ फोर्स कर अप्लाई किया वो ऑब्जेक्ट को लिफ्ट करने के लिए, लेकिन वो उठ ही नहीं पाया. इट वॉज नॉट पॉसिबल फॉर मी टू लिफ्ट दैट ऑब्जेक्ट फ्रॉम पॉइंट ए एंड प्लेस इट इन बी. सो आई विल से देयर वॉज नो वर्क डन. हमने काम किया लेकिन वर्क तो नहीं परफॉर्म हुआ ना. दैट्स व्हाट इज वर्क. सो फॉर वर्क आई नीड टू अप्लाई फोर्स एंड मूव और डिस्प्लेस दैट ऑब्जेक्ट फ्रॉम पॉइंट ए टू पॉइंट बी. Okay, so if twice the force is applied, twice the work is done. If an object moves twice the distance, twice the work is done. Vice versa. Next come power. So I told you that I want to lift an object from point A and shift it to point B. So whatever force is required, and now I want to move it. Yes, I was moving it from point A to point B. How much distance was there? So that was work done. That is, I displaced the object from point A till point B. So this was work done by me. And अभी ये तो काम कर लिया, अभी ये तो सब कर सकते हैं. तो कोई फास्ट करेंगे, कोई स्लो करेंगे. So to explain that, the next terminology came, that is power. That is rate of doing work. How fast I was doing. I was doing it in just 2 seconds, and some other person came and he took 5 seconds. So this is how we are going to differentiate between the power delivered by particular motor A and the power delivered by motor B. So to distinguish between these two, I need to use this, that is what should be the power. Now why we need this? Because वो मोटर की, वो ड्राइव की कैपेबिलिटी होनी चाहिए उतना ऑब्जेक्ट, उतना जो एप्लीकेशन है वो रन करने की. अगर उसकी कैपेबिलिटी नहीं है, वो स्लो काम करेगा तो हमारा काम नहीं बन पाएगा. इन स्टील रोलिंग मिल्स, इन टेक्सटाइल मिल्स, सो देयर पावर इज वेरी इंपॉर्टेंट. ओके, सो हाउ दे डिफाइन पावर? दैट इज नथिंग फोर्स इनटू डिस्टेंस. काम तो करो लेकिन वक्त के साथ करो. दैट इज फोर्स इनटू डिस्टेंस अपॉन टाइम, रेट ऑफ डूइंग वर्क. ओके, सो नेक्स्ट इज horsepower, the last one. As I already stated in starting only, so horsepower is nothing but torque into rpm divided by 5250. So this is a constant actually. So horsepower comprises of torque as well as speed. rpm stands for revolutions per minute. So torque into speed divided by 5250. So this is a person used to prepare a sold steam engine, and so one day he was being asked what a question I already stated. So this was the answer which he produced, and in this case, so by this equation only we get the applications like constant torque से काम करना है, constant speed से करना है, या torque और speed बराबर चलने हैं, या torque कम करना है, प्रोपोर्शनली इंक्रीज करना है, या स्क्वायर में इंक्रीज करना है, इन्वर्सली करना है. ये सब इसी फॉर्मूले से डिफाइन होता है. Okay, and every time I know power will be constant, so either of these terms should be in a position. अगर टॉर्क बढ़ता है तो ऑटोमेटिक आरपीएम कम होना चाहिए, तभी मेरी हॉर्स पावर कांस्टेंट रहेगी. अगर आरपीएम बढ़ता है तो टॉर्क ऑटोमेटिक कम होना चाहिए, so that my horsepower will be constant. Okay, so this was whole for terminologies used in drive. These are seem to be very simple terminology, but it's very important for selecting a motor in a drive. So the reference is Siemens Step Technical Educational Program Manual, and this was a question for you. So thanks for listening.